Okay, sorry about that. My sister popped in to pick up my nephew. He was playing with Braxton. So, just a second. What, buddy? Okay, that's fine. Again, sorry, we've had lots of interruptions today. But anyway, when we're talking about erythrocytes, okay, erythrocytes are those red blood cells, that reddish mass that falls to the bottom of the test tube in when we do put it in the centrifuge. The red. Okay, that's fine. The red in it is the transporting oxygen. Okay, the erythrocytes, that's their job, is to transport oxygen. The buffy coat, that very thin layer, that less than 1% of the total amount of blood, it's a whitish layer, okay? It's between the erythrocytes and the plasma. It kind of separates the two. And that's where we find leukocytes and platelets. Leukocytes. When we're talking about defining leukocytes, we're talking about white blood cells. If we think of white blood cells, we should think of those fighter cells, those things that protect our body by fighting off antigens. And then the platelets are sometimes in medical terminology, we call them thrombocytes, okay? But they're just pieces of cells, fragments of cells that help stop bleeding. Okay, when we look at hematocrit, hematocrit is a term for fraction, okay? It's a fraction of looking at the percentage of the total volume of blood. So if we're looking at plasma, plasma is 55% of the blood. It makes up 55% of the blood. Erythrocytes about 45, and then that buffy coat, like I said, is less than 1. So the erythrocytes and the plasma are a little bit off, vary from time to time, maybe 44 and 55 and then 1% of buffy coat or whatever, but it's roughly around those numbers. Okay, when we're talking about the physical characteristics of blood, we are all familiar with blood. We've all seen blood. It's kind of sticky. It's opaque. It's got a characteristic kind of metallic-y taste. We notice probably as kids that it kind of tastes a little salty. And everybody says, "Oh, how do we know what blood tastes like?" Well, we all have had, a little cut or something that we put our finger in our mouth to kind of stop the bleeding. So that's how we know that metallic kind of salty taste. Okay, the color of blood varies. Now, it's not going to vary from blue to purple to red, but the color of red varies depending on how much oxygen that it's carrying. Okay, so if it's really, really bright red, it's very oxygen rich. Okay, if it's kind of a dull red, then it's more oxygen poor. It's heavier than water and about 5 times thicker. Okay, the temperature of our blood is always just a little bit higher than our body temperature. Okay, you guys probably haven't had too many test tubes in your hand, but if you were to grab the test tube, hold the test tube after. There's been a couple times where a phlebotomist has kind of been juggling things, and I'll hold the test tube for him, and it always does. It feels just a little bit warmer to my touch than like my body temperature would be. Okay, then the other part of that is the plasma, okay, which is made up about 90% water, and it's kind of straw colored like in this picture here on the right. Okay, getting a little more specific into erythrocytes. They're, again, remember, red blood cells. Okay, we abbreviate that RBC, and their job is to carry oxygen to all the cells of the body. Okay. They're very, very efficient in oxygen transport because they do not have mitochondria. And what do mitochondria do? They are the powerhouses. So they're using up a lot of that. Mitochondria use up a lot of oxygen to create that energy. Okay. So if a cell doesn't have a mitochondria, then they're not using up a lot of that oxygen. So all the oxygen that it's transporting, it's able to use. It's not being used up in the process on the way. Okay, when we're looking at erythrocytes and hemoglobin, remember hemoglobin is that oxygen or the iron part of the cell that's carrying most of the oxygen. Okay, as our blood cells thin, or as our red blood cell or red blood cells decrease in number, our blood thins, okay, and flows very rapidly. As far as efficiency in oxygen transport, the number of hemoglobin molecules is more important than the actual number of red blood cells. So if the number of hemoglobin cells within each red blood cell or molecule within each red blood cell is high, then the oxygen transport is going to be great. Okay, so more hemoglobin means more oxygen transported. Looking a little bit more closely at leukocytes, and you guys are very lucky this year because normally we study all the different types of leukocytes, like you can see in the top picture here, neutrophils and eosinophils and basophils, and they have to know the difference between all of those. We're skipping through all of that. We're just going to learn that leukocytes are white blood cells. There's a lot less white blood cells in blood than there is red blood cells, which we can see that when we look at the tube, the test tube, and when we're looking at that teeny tiny buffy coat compared to the big section of red blood cells or erythrocytes. Okay. When leukocytes, their job is to fight, right? It's to protect us against bacteria, viruses, parasites, tumor cells, all those things. Okay, so if we get a bacteria in our body and the white blood cells say, hey, let's go fight this off, we can't let Ashley get down, then the production just increases like crazy and we get more and more and more and more white blood cells. You can actually, like, as soon as an infection comes in, within a few hours, your number of white blood cells can double, okay? Twice as high within just a few hours, okay? So our leukocytes really, really flood in and really increase to fight everything off to keep us healthy and safe, which is encouraging, especially with everything going on right now. Platelets. Platelets, remember, are used for clotting. Okay, they're not really cells in the sense that when we're defining cells and like we have earlier in the year. Okay, but they're just kind of fragments of cells. Okay, the normal platelet count is about 300,000 cells. Okay, it's necessary for clotting. I can't remember how much I've talked to you about it, but Braxton had a platelet issue a few years ago when you seniors were freshmen. In the middle of basketball and wrestling season, Braxton had a platelet issue, and it was a very, very frightening time for us. But he was horsing around in the weight room with his best friend, one of the wrestlers, and he came back, and the next day he had all these bruises, and I thought he was just being a normal kid, you know, horsing around, and that they had played hard. And then as time went on, he just kept getting more and more bruises, and his little body was just covered and covered in bruises. And he had these pinpoint little teeny tiny bruises under the skin. They were unlike anything I've ever seen. And the skin was, it felt normal. It wasn't like raised or bumpy or anything. It was just like little bruising. Long story short, rushed him to the doctor because I was terrified that he had leukemia or something. Of course, my mommy / athletic trainer brain was going nuts. But he had a really low number of platelets. Normal is 300,000. He had 7,000. Okay, 7,000. So his blood was not clotting at all, in the very least. Okay, because his body it thought his platelets were part of a virus that he had been fighting off, and so his body attacked. It was a temporary autoimmune disorder, but his body was attacking his own platelets, just knocking them off. Okay. Traumatizing, very, very scary time for us. But as you know, now he's a normal, healthy animal. So we were very lucky that that was very short-lived. And it was kind of cool because we kept testing. Once we found out he was okay, we kept having to test, and we could just see those white bloods or those platelet cells just going up, 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 up. We haven't had it tested for a few years, but I have an order where I can get it tested anytime I want if I'm worried about the bruising again. Two big terms for us to finish this up. The first one, hematopoiesis, okay? And you probably remember way back when Poiesis is formation of blood cells. Okay. You also, I'm sure, remember that it occurs in red bone marrow, which in adults, that would be in flat bones like ribs, sternum, and then the proximal epiphysis of the humerus and the femur. Okay. There's a term from way back when. But each type of blood cell is produced in different numbers, so different quantities in response to whatever's happening in the body and different stimuli. The last term that we're going to talk about for blood is hemostasis. And we look at that and we think homostasis, right? And it's kind of similar, but it's more for blood. But hemo means blood. Stasis means standing still. So it's the stoppage of bleeding, okay? Blood flow normally flows very smoothly when our blood vessels are intact, okay? If the blood vessels are just normal blood vessels, everything's intact, it just flows on by, not much happens. When there's a little break in the wall or a little irritation there, sets off a series of reactions. We're not getting into all of those, but basically gets that blood to clot, okay, which is hemostasis. That clotting typically occurs within 3 to 6 minutes. Okay, if you can think about someone maybe walking or pushing one of those walkers along a rug. Okay, and if you're walking along the rug and you the rug just kind of lays flat and you don't get your foot kind of caught under it or one of the wheels of the walker caught under it, you can just roll right across it, no problem. You just keep on going. You just keep smooth, just a smooth walk across the rug. If that rug gets flipped up or your toe catches a little bit of it, what happens? You start to stumble, you start to fall, right? That's the same thing with hemostasis. Okay, so as long as everything's smooth, that blood vessel wall is intact, it can just keep on flowing past. But once there's a little break, a little ripple, a little irritation there, it's going to stop and catch it up, and then the blood clot will form. I know that was really fast. You might feel like it was really long for me to talk, but I wanted to make sure we got through all this blood stuff today. And then we're going to do a little review activity, and then we're going to move on to something new tomorrow, okay? We're going to keep exposing, like I said, to just different things really quickly to get through, and so you're a little familiar with everything. And then we're probably going to spend the last week, those last few days, doing some like review, just kind of wrapping things up. Okay, so that's kind of my plan so far. We'll see. Everything seems to be kind of changing here daily, but that's my plan. So if you have any questions, any concerns, please let me know, okay? Talk to you guys later.